Hi, everybody. In this video, we're going to go through lesson 1.5, build linear functions. So to start off, I want to review that functions have inputs and outputs. And each input or x value has only one output or y value. And we can see functions, like visually, we can see them in different ways. So they can be represented by a graph, by a table, by an equation, by a set of points. There are lots of ways. And honestly, I'm gonna go dot, 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 because there are more. We could verbally describe it. We could see it in real life. We could just analyze some real life situation. So I want to begin by exploring a little bit. So we are going to I'm literally calling this explore. We're going to create an input output table for the function. So this is going to be a function down here, 7x minus 7y equals 21. So I don't see my f of x. This is really a function equation. And the reason we would want to create an input-output table for this function equation is so it can be graphed. So we have xy points that work for this function. So if I have this function equation 7x minus 7y equals 21, and I want to create some value of x and y tape, like some xy table, I probably want it to be y equals something, right? So that this is like f of x, or our output is equal to all of that. So I'm going to have to do a little bit of algebra to get it so that y is all by itself. So really what we are going to do here is solve for y. Try to get y by itself. First thing I'm going to do here is move this extra, this 7x, away from the side that has y, right? If I look at this equation, it has two sides. The left side has y on it. So I'm going to move this 7x over to the opposite side by subtracting. This is a positive 7x, so I will subtract 7x from both sides. Positive 7x minus 7x is 0. So we're left with just the negative 7y is equal to 21 minus 7x. Yes, you can just leave it like that because we don't know what x is. And now to get y all by itself, this is negative 7 times y, so I'm going to undo the multiplication by dividing both sides by negative 7. So I divide the left by 7, and the entire right side gets divided by negative 7. And essentially, I'm going to distribute this division here. So the negative 7 divided by negative 7 on the left cancels. We're left with just y equals. And then we have 21 divided by negative 7 minus 7x divided by negative 7. So I just distributed that division to both the 21 and the 7x. So I'm going to divide both of those terms by negative 7. And that looks like an arrow more than a negative 7. Ooh. Now, just dividing, y is going to be equal to 21 divided by -7 is -3 minus 7x divided by -7 is -1x, and minus a negative is really just a plus. So altogether, this equation is y is equal to -3 plus 1x, or just x. And we could even go as far as rearranging these terms and make it y is equal to x plus -3, or y is equal to x minus 3, because I can always flip terms when I'm adding. So now I can create my input-output table. So I'm going to have my table of x values and corresponding y values, which really this is the same thing as f of x values. So if I'm going to graph this function, and I'm picking x values, oops, we're going to try it again. Generally, we want to pick nice x values. We are going to use the x values of 0. We're going to start with 0 first, and then kind of go from there. So if x is 0, I'm actually going to change this a little bit. I'm going to make this column our equation y is equal to x minus 3. And then we'll put the final output value in this last column over here. So if x is 0 in our equation, to find y is equal to x, which is 0, minus 3. And 0 minus 3 gives me -3. So this first point is the point 0, comma, -3. Now I'm going to see what happens when x is 1. So where I saw x in my equation, now I'm going to have 1. So we have 1 minus 3, which equals -2. So this is the point 1, comma, -2. Oops, I switched colors. Okay, now let's see what happens when x is 2. So I also want to remind you, if I'm letting x equal 2, this is really the same thing as finding f of 2, which equals whatever we get when x is 2. So I will subtract 2 minus 3, and 2 minus 3 gives us -1. So the point 2, comma, -1 is a point on our line. All right, and then let's see what happens when we have a negative. So now I'm going to find when x is -1. So this is the equivalent of finding f of -1. So if I let x be -1, we have -1 minus 3, and -1 minus 3 gives us -4. So I have the point -1, comma, -4. So these are 4 points of x, comma, y values that satisfy this equation, that work for this function. So I know that f of 0 is -3. That's a point on the line 0, comma, -3. So function notation really is just another way of looking at what our input or our x values are and what our output or our y values are. And I also want you to note that each x, comma, y value satisfies the equation. So that means if I take the x value of 0 and the y value of 3 and I substitute them into our original equation, remember our original equation was 7x minus 7y equals 21. So if I let x equal 0, when I'm substituting values in, I always like to just create my little sets of parentheses, my little homes for our variables. And remember x, that was, let's look up top, x was 0. So if I let x equal 0 and I let y equal -3, it's going to equal 21. And let's see what happens. So -7 times, or sorry, 7 times 0 sure is 0. So that just kind of goes away. And then -7 times -3 is positive 21. So I have 21 is equal to 21. So each point satisfies. Let's look at some examples of building linear functions now that we've kind of played around with them. So we are going to begin by graphing the function y is equal to -3x plus 2. And I just realized I did not get a graph for us to use for this. So let me see. We can just make one. I'll show you how I build a graph by hand. I always start by just drawing my x-axis. And then I try to make my y-axis about the same length, cutting the x-axis in half. And if it's not perfect, it's not perfect. And then I see how many values of x I want to use. I always think 5 is good. So if we just create 1, 2, 3, 4, 5. So this is x equals 5. And then we'll go the opposite way. So -1, -2, -3, -4, -5. And then we'll go up 1, 2, 3, 4, 5. And we'll go down. 1, -1, -2, -3, -4, -5. Okay, so to graph this function, this is an equation, right? This is the function equation y is equal to -3x plus 2. This is really like f of x is equal to -3x plus 2. And really to graph this, you need 2 points. Yes, you can use your slope and your y-intercept, but at the core, you just need 2 points. So you could do slope or your m value and the y-intercept, which some of you would prefer, or you can create an XY table. And we only need 2 points, which is what we're going to do. So I'm going to create a little XY table here. And our equation is y equals -3x plus 2. So I need 2 points. I'm going to pick nice numbers. I'm going to start with 0. 0 is always my favorite value to use as x because it cancels things out. So our equation f of 0 is the same thing as letting x equal to 0. So that's going to be -3 times 0 plus 2, which gives us just a y value of 2. So we have the point on our graph 0, 2. So I am going to plot that point. I'm going to go neither left nor right. I'm just going to go up to 2. And that is the point 0, 2, which represents that f of 0 is equal to 2. Now, I need another point, and I have 2 options. I could do a negative, I could do a positive. I'm going to do +1. So I'm going to find f of 1, which is the same thing as letting x equal 1 in our equation. So that is equal to -3 times 1 plus 2. And -3 times 1 is -3 plus 2 gives us -1. So this tells me the point 1, -1 when x is 1 and y is -1 is a point on our graph. So I'm going to go over to the right 1, representing when x is 1, and then I'm going to go down 1 unit for -1. And this point here really represents when f of 1 or where f of 1 is equal to -1. And now that I have 2 points on my graph, I can create a line. And I have the technology to make it beautiful. You have a ruler, hopefully, or a straight edge also works. Okay, I want to look at another example. We are going to write the slope intercept equation of the linear function represented by the table. All right, so here is my table. We have x, like that, a little bit longer. We have x and y values. Our x values are 1, 3, 5, and 7. And our y values, when x is 1, y is -3. When x is 3, y is 3. When x is 5, y is 9. And when x is 7, y is 15. So I want to remind you that if we are asked to find our slope-intercept form, according to our formula sheet, according to notes we already have, is the form y equals mx plus b, where m is our slope and b is our y-intercept. So we need to find these two things. So our y-intercept, our b value, that is where we cross the y-axis. And remember, that is where x equals 0. And I don't see where x is equal to 0 on my table, so I can't see it visually here. I'm going to have to dig for it a little bit. So we should begin by finding our slope. Now, to find the slope between 2 points, we will use our slope formula, which is y2 minus y1 divided by x2 minus x1. And I really just need 2 points for this, so I'm going to pick 2 points. My first point, I only want positives. You can choose negatives if you want. I don't want to. So I'm going to choose these 2 points. So my x1 is 3, my y1 is also 3. Coincidentally, my x2 is 5, and my y2 is 9. So now, using my slope formula, I always like to set up my structure first. I have a fraction, 2 things being subtracted, right, in the numerator and the denominator. My y2 value we labeled as 9, minus our y1 value we labeled as 3. So now I'm just filling in our pieces. Our x2 value we labeled as 5, minus our x1 we labeled as 3. And then I can simply subtract here. 9 minus 3 is 6, and 5 minus 3 is 2, and 6 divided by 2 gives us 3. So our slope, or our m value, is 3, meaning in our equation y equals mx plus b, this m value we now know is 3. So the question is, what is b? To find b, to solve for b, I can plug in values of x and y that I know work for this equation. And I have some. So I can pick any of these points. Let's spice it up. Let's pick a negative. So we're going to choose a known x comma y. So I am picking the point 1 comma -3. So I'm going to let x equal 1 and y equal -3. So in my equation, y is -3, and we don't really need parentheses around that. And that is equal to our slope, or our m, times x, and x for this point is 1, plus our b value. So this is our y equals mx plus b. Now I really just solve. We can solve for b. 3 times 1 is 3. So we have -3 equals 3 plus b. And to get b completely by itself, I will subtract 3 from both sides. Now -3 minus 3 is -6. So we get our b value is -6. So putting it all together, we get, or we have our slope of 3, our b value of -6. So our slope intercept form, our y equals mx plus b, is y equals 3x plus -6. And all together, that is really just the same thing as y equals 3x minus 6. All right, I'm gonna make a separate video going through a word problem on linear functions. So please take maybe a little brain break and then come back and watch that video.